So next up is Kathy. Kathy's very involved with the direct broadcast work that goes on here in CIMSS. And so I've asked her to come up and talk a little bit about what's going on, because there's all kinds of stuff happening in terms of research, education, and outreach type activities. And I'm not sure which one she's going to focus on, if any of them. But Kathy, thanks. Lights.
Thank you. I'm going to talk about satellite direct broadcast activities, and along with my colleagues Liam Gumley and Alan Wong, we have a real passion for supporting the direct broadcast community. So it's really important that what we do is useful to people. And of course, it's not just us three. There's a lot of people who work on these projects, and I tried to list all the names I can think of, and I'm sure I left some out. But it's not just people at SSCC, it's also people in the country, outside the building, and also globally. So we work with people like our brothers and sisters at Nova Star, as well as a lot of global Met services, including the German Weather Service, Taiwan Central Weather Bureau, UK Met Office, the Indonesian Agency for Meteorology, Climatology, and Geophysics, amongst others. So I'm going to talk about the Polar Orbiter Direct Broadcast, which is the real-time transmission of data, Earth observations from the satellite to the ground. And I know there's other direct broadcast activities that are going on probably in the building, but these are the ones that I know about, and that's what I'm going to be talking about. And specifically the polar orbiters Aqua, Terra, and then Suomi NPP. So with these instruments, the data are free and clear with no encryption. So all you need is an antenna and a receiver, a large antenna. And because this data is free, we get comments like from our colleague Vladimir from Scanx in Russia, Terra and Aqua are a great gift to the world. And it's true, the fact that this data is free is not common amongst other groups. So when I talk about an overview of our activities, I like to break it up into categories. The first one is the real-time data acquisition, processing and distribution of data, where the timeliness of the data is vital. So right now we have two tracking antennas, which means real-time acquisition of the Aqua Terra satellites from NASA, Suomi NPP from NOAA, as well as MEDOP and POES. All of our data is freely distributed. Some products are customized for specific users. And we also support our own things like field experiments, as well as the web mapping services in the center and other things as well. The next category is software development and distribution, which provides the capability for users who have an antenna. Once they acquire the data, they can actually calibrate it, geolocate it, and create science products, which supports their local research and environmental monitoring, as well as our own here at the center. For example, it's a way for the science team members, from people who work on like Beers or Chris or Modus, they're able to test their products prior to integration into something like MODEPS, which is the NASA processing center. We also have an education division, which we think of in the global direct broadcast workshops that we do, part of global outreach. People say, well, now that I'm able to acquire the data and I have the software, I can create the products, how do I use them? So I'm going to talk about that in a minute. And then also along with that is a tool that was developed for teaching, visualization, and analysis of Paul Menzel and the lead software engineer, Tom Rink, Hydra, and Hydra 2. So the center has a a long history of supporting direct broadcast for polar orbiters, starting with IMAPP and then ITPP. And then in 2000, NASA funded the International Modus Airs Processing Package, which supports the Aqua and Terra satellites. And with that, we acquired an antenna, a TerraScan 4.4 meter dish. Then in 2011, NOAA funded the Community Satellite Processing Package, which at first primarily supports Suomi NPP. And along with that, then we have a new antenna that we acquired from Orbital Systems. And the goal of all the software is so that DB users can now create their own local products for their own local applications. So the first antenna that we acquired of this series was the TerraScan antenna for Aqua and Terra. And here's the antenna itself. It was placed in this radome, which looks like a soccer ball, lifted by this heavy lift and helicopter on top of the tower on top of our building. And since we're located here in the center of the country, over a lot of North America. And then in September of 2011, that's when we got the orbital systems antenna, and it was placed on top of this engineering building on campus. And this is a typical set of passes then for SUNY NPP. So I'm going to talk about first the IMAPP package, which again is the International Modus Airs Processing Package, funded by NASA, supports Aqua and Terra, and since we've been funded for more than 12 years now, we've released 48 different software packages. We have more than 1,500 registrants from 70 different countries, and we've only been keeping track of these things since 2007. In that time, we've held 10 direct broadcast workshops on 5 continents, where we've taught students from more than 60 different countries. And out of those 48 packages, 13 have been related to MODIS. Out of the 48, which is the imager, 6 have been related to the AIRS hyperspectral sounder, and 4 related to the microwave and SUNY instrument, which now currently is not functioning anymore. And all of our software is freely available through our website, which is off the CIMSS webpage. And if you go to the download button, you can actually register just with an email address and then have access to all the software. So again, we've been doing this for a long time. The IMAPP software suite is pretty big now. It includes everything from atmosphere and Jeff Key's polar products to MODIS land products, land surface reflectance, and bidirectional reflectance distribution function, BRDF, which was provided to us, and we worked with Boston University to do that. Liam packaged up an image software package called MODIS and Google Earth, which allows you to create full resolution true color imagery, 250 meter, that you can display in Google Earth. We have some AIRS level 1 and level 2 packages, including ones from JPL, as well as our own in-house single field of view dual regression product. There's AIRS utilities, co-locating AIRS and MODIS. We worked with the UK Met Office to release an AIRS HDF to buffer utility that was requested by the Bureau of Meteorology for their assimilation products. If you have R-type ANSWER E data, you can still create, you can still calibrate and create products from it. And then we started actually supplying people with application software packages, including EBCRAFT, the Direct Broadcast SIMS Regional Assimilation System, which was created by Bob Ani. It's globally configurable, and so you can create your own domain. And the unique thing about it is that it actually assimilates the MODIS products that you create from your antenna, so that it improves the depiction of clouds and moisture in the model based upon your own products. We also released the Overshooting Tops product, which was Chris Bedka's, and that was included as part of the GeoCat suite from Mike Catalona, so we released that last year. We have an air quality forecast product, which I'm going to talk about in a minute. And then Liam even packaged up a complete Aqua and Terra direct broadcasting system, direct broadcast processing system, in the form of a virtual appliance that can be then installed on Mac, Windows, and Linux. So I talked about the global user database, includes 70 different countries, which I did the math, is greater than 1/3 of the total countries in the world. And if we look at the geographic distribution of those users, it includes people from all seven continents, including Antarctica, because it's installed and running on a system that Lazara runs with AMRC in Florida. So if we move on to CSPP, which is the Community Satellite Processing Package, NOAA's been funding us to do that since 2011. Right now, it primarily consists of supporting the SUNY NPP satellite, and so we released the calibration and geolocation software for VIRS, which is the imager, ATMS, which is the microwave instrument, and CRIS, which is the hyperspectral sounder. We've also released level 2 EDR software for the VIRS Cloud Mask and Active Fires product. And then on top of that, we released what we call value-added products from the UW, including the hyperspectral retrieval product from Nadia, Bill Smith, and Elizabeth Weiss. And that supports CRIS, AIRS, and EASI. And then we've also released what we call the Polar to Give reprojection software package, which now produces, it's a Python-based tool which supports the back end of AIRS format as well as GeoTIFF. So that software is released through the CSPP website. And the user database, if we look geographically, now includes more than 300 registrants since we released the first package in March of last year. And it even includes all 7 continents also. So let's look at some of the applications that we support with from the software and from our antenna. It includes everyone from the National Weather Service to the Forest Service to NASA Sport, as well as the Canadian Eye Service and NRL, as well as some air quality agencies. So here's an example of how the imagery is used by the Great Lakes node of NOAA's Coast Watch. If you go to their web page, they have a MODIS link here, and if you click on that link, it takes you to 250-meter resolution true color images that we provide for them so that they can monitor things like ice growth over the northern part of Lake Michigan. The national supplying data to the National Weather Service has been a big success story for us, thanks to people like Jordan Girth and the Proving Ground team. When we first started doing this in 2006, Jordan came back from Sullivan Weather Service office and told me, okay, they're interested in looking at the data, maybe using it, but you have to answer one question for them. Can research satellites be used in operations? So they weren't really even sure whether polar orbiter data could be used. So after starting with that and one office here in Sullivan, we now supply 59 different forecast offices with the MODIS data that we acquire from our antenna, process, and ship out to them. So I think the answer is yes. We've convinced them and ourselves that it is useful. So to make sure that the data and products are useful and find out how we can improve the delivery, we've been monitoring how many times MODIS has been mentioned in the area forecast discussions as a decision-making tool. So since we first started doing this in 2006 through the end of 2012, MODIS has been mentioned more than 350 times in area forecast discussions. And just as an example, there was an area forecast discussion issued just yesterday by the forecasters in Marquette, and this happens to be the hydrology forecaster, who was looking at visible satellite imagery as well as the MODIS of full high-resolution imagery to look and see the extent of the snowpack that's still left in northern Wisconsin and the UP because they're concerned about flooding. And if we look, I think what they actually look at a lot is the true color and false color imagery. So here's Marquette, and you can see, as of yesterday, there still is a large snowpack, even over southeastern Minnesota. What a bummer. Okay, another thing we support is air quality forecasting. So we released a package called Infusing Satellite Data into Environmental Applications International, IDEA-I. And it's an end-to-end package which uses the MODIS aerosol optical depth product to define areas of heavy aerosol loading, which we define as aerosol optical depths greater than 0.4. And then once you identify those locations, you initialize trajectories, run a 48-kilometer trajectory forecast to tell you vertically and horizontally where those aerosols are going to go. So this package includes both creating the aerosol optical depth product, identifying regions of heavy loading, and then running the package as well as the PHP and the imagery to display these over the web. And the output product actually consists of an SCDF file with hourly trajectories. And this was a domain, so it's globally configurable. This was a domain that was set up at the request of an air quality forecaster in Oregon. There was, and this dated in October of last year, there were fires in this region of the northwest U.S., and there was aerosols that were actually pooling in Montana. And so this is a 48-hour trajectory forecast as displayed through the web. And I was wondering whether this domain was even useful to them, and so I asked, and Sarah Strachan from the Idaho Department of Environmental Quality wrote back and said, this domain is quite useful, which is what you're hoping to hear from the user. Okay, so let's switch over to another domestic application, VIIRS data used in Alaska. So we received funding by Mitch Goldberg as part of the JPSS High Latitude Proving Ground to support National Weather Service forecasters in Alaska with VIIRS data. So the steps that we went through was that Liam installed the DB virtual appliance software at GINA, which is the Geographical Information Network of Alaska, located at the University of Alaska Fairbanks, where the antenna is housed. Polar to Grid software was then created so that it's a portable tool that reprojects and reformats the data to the NetCDF files that are suitable for display in AWIPS. It's a Python-based tool with Dave Hayes as a lead software engineer in that project. I traveled with Jordan to Alaska. We completed the installation and delivery system, and then we trained the forecasters in Fairbanks and Anchorage in the use of the data in operations. And this is a picture of Jim Nelson, another Jim Nelson, who is a science officer in Anchorage, forecast office, who's looking at one of the first viewers images they could display in AWIPS. And so I asked Jim also to tell me, is this data useful to you guys? And he wrote back and said, the VIRS data are useful for sure, which again is exactly what you hope to hear from users. And then this is an example of area forecast discussion that was issued where it mentions the VIRS day-night band and how they're using it to help them discern a very complicated system at that time. This is from Juneau. And then Carmen Scott from Anchorage wrote back and said, this is a breakthrough, as there's been a general reluctance to integrate LEO imagery in their forecast process. So we're really pleased with how this worked out in the end. And then, since we had the system then, to go from direct broadcast all the way to the end user in AWIPS, we decided to install it on our own system, leveraging all that work we did. And so we then started supplying it to the regional offices. And I sent a message to Chad Gravel, who was our one of the satellite liaisons for us, and asked him if he'd heard anything, whether this data is being used by anyone. And he wrote back and told me that the forecasters in Monterey are using it to help them with confidence in forecasting and evaluating the extent of fog. And if you look at an image, this is one from a couple weeks ago, where this is a day-night band, so this is actually nighttime. You're looking at solar reflectance, which is coming from the moon. And this is nighttime, and you can see the extent then of this maritime stratus, exactly how far it's penetrating onto the coast, and even into the extent of how far it's moving into the valleys. It really is a unique tool. When the moon is full, it really does look like a visible image at night. That's what it is. So we also leveraged that work to also supply polar data to forecasters in Hawaii. So CIMSS actually won a NOAA proposal to install an XL band antenna and polar orbiting processing system in Hawaii in support of the National Weather Service. So Liam Gumley was the project manager, and he was on site for that installation, as well as Jordan, I believe. So the MODIS and VIRS processing systems were installed, as well as the polar grid software. And there's Liam doing the hard work of attending the installation in Honolulu at the community college there. And we've been in contact with Jordan, who is our liaison to the Pacific region, and he tells us that VIRS data does appear to be being used, as well as things like they issue a satellite interpretation message where they use VIRS day-night band. And if we look and see why this data might be useful to them, this is a typical GOES product, infrared band at night over the Hawaiian Islands. And I'm sorry that these are oriented north to south, but from our CONUS perspective, that's what it looks like when you get there in AWIPS. So what I'm not showing, of course, is the temporal resolution 15-minute imagery that shows you where the clouds are going. But if you look at the 1-kilometer imagery from VIRS, you can see a lot more detail, which complements the geo. And then on top of that, when the moon is full, you also have the VIRS day-night band providing you with, again, visible data at night. And Scott Bachner and Scott Lindstrom have now come up with a teletraining, VisitView teletraining session called VIRS Imagery in AWIPS. And we're hoping that this provides the increase in use of the data in AWIPS as the module that Scott put together, which was MODIS imagery in AWIPS. It really promoted the use of the data by the forecast offices. So I thought I'd quickly mention Bill Smith, Elizabeth Weiss, and Nadia Smith. Their hyperspectral retrieval sounding package, which just been updated, version 1.1, has just been released. And Nadia actually gave a nice talk at this at the last CIMSS Science Symposium. So this is the retrieval package that works on hyperspectral instruments, including AIRS, YASI, and CRIS. And we just released that package. And the reason I want to mention this too is because this is a really popular product. When we released this last November, within 24 hours, we had 50 new CSPP registrants. And one of the reasons for that, or the main reason for that, is not only that it's a good quality product, but also it's the only publicly available level 2 retrieval package that's available for YASI and CRIS. So it not only creates a lot of the typical retrieval products like temperature and moisture profiles, but it also provides information on clouds as well as surface properties too. And then I thought I'd mention that we get lots of requests for imagery, especially on special occasions like Hurricane Sandy, where Mitch Goldberg requested us to create a nice image for a press release of Hurricane Sandy at night, day-night band as soon as we possibly could. So Liam stayed up that night, waited for us to get this overnight pass and processed it and sent it to him. Mitch, which he used as part of the JPSS press release for Hurricane Sandy. And if you look at this, again, this is data acquired from our antenna, and you can really see the low-level circulation as well as the upper-level circulation on this day, 27 October. So this is a nighttime visible image. And what I guess I like about this image too is that you can actually see the city lights in populated areas in the northeast where it eventually was going to affect. So I talked about domestic applications. I'm going to talk about some of the global applications that we support too. I mentioned DB-CRAFTS, the Direct Broadcast SIMS Regional Assimilation System. This has been installed in a few places around the world, including Hungary. So there's a young woman and her husband who pretty much have charge of their antenna, and they installed DB-CRAFTS as a forecasting tool in support of her country's forecasters, amongst other people. So this is available over the web, and this happens to be an 850 millibar set of fields. And they also supply their country with mediograms created from NDB-CRAFTS, which is the nested product. And again, these are available. You can look at these at any time. We had Katja Hunkeshofer, who spent a month with us last summer because the German Met Service was very interested in getting VIIRS data to be able to be displayed in their visualization and analysis system, which is called NINO. So now there is a polar-to-grid software package backend that includes NINO formatted files, which are a specific type of geotip. So this is an image that Katja sent me, which is just VIIRS data displayed amongst MediaSat as well as other products overlaid on it in NINO. So UMETSAT has chosen CSPP to be their software package for Suomi NPP as part of the Advanced Retransmission Service, which is a way that they connect all of their direct broadcast users and make the data available quickly to all that fall within the range, which is this set of antennas that they're supporting. This is taken from a poster that Christelle Ponsard sent me that was used in NetSat meeting last year. And so here's where they describe how they're using CSPP. And the last thing I thought I'd mention about this is that at the bottom here, what they're saying is that they want us to become one of the sites that's included as part of the retransmission service in the future. In South America, we know that the IMAPP products and CSPP products are being used. You can go to the APCP Tech Brazil site, the website, which is their environmental and satellite center, and they have IMAPP products displayed in real time. This happens to be a TPW IMAPP product, and they use a lot of retrievals. So they're very interested in temperature and moisture profiles because they use them not only for NWP purposes, but also for real-time forecasting. So they actually performed a field experiment, held a field experiment in 2008, where they took a look at a lot of different satellite retrieval techniques and compared those with radiosonde. So here's an example of some of the different products that they were looking at, including AIRS, IMAPP, MODIS, and Aqua and Terra retrievals. And what they found was the AIRS Level 2 was the best one at retrieving low-level surface features, including inversions. So if we go to Africa, we've worked pretty closely with the CSIR folks in Pretoria, South Africa, Philip Frost and his group. They actually requested for us to create a new DB-CRAFTS output field, which is called the Fire Danger Index. So we did start supplying that, and this is their implementation of DB-CRAFTS, the Fire Danger Index over the southern part of Africa, and they use this then to send out to their field supervisors who then know how closely they have to monitor based on this 3-day DB-CRAFTS FDI forecast. And then we also know that DB-CRAFTS is being used by on-air meteorologists. Candace McKechnie and this young guy, Eric Van Dam, who's actually from Michigan. He does a South African forecast. And they actually both came to our center in December, right before the big snowstorm. And Candace McKechnie sent me this note in 2010. She said, the strength of DB-CRAFTS lies in the finer spatial resolution. And she said it picks up local conditions more accurately. I think it has improved our forecast. So now you can retire, Bob. You've heard those words. Sorry. Okay. When we released the Polar to Grid software with the GeoTIFF backend, the South Africans, it was a full moon case, and the South Africans were so pleased with the output that they actually sent me their first pass that they created. So this is a day-night band image, so it's a nighttime acquisition of a scene which happens to include a cyclone, and this is the close-up of that cyclone. Again, this is a nighttime image. It's Cyclone Haruna, which is off the coast of Madagascar, and it's a beautiful image, as well as some other things you can see, including Johannesburg, Pretoria, and Durban through the clouds, as well as this fog that is intruding along the west coast of the continent, east coast, excuse me. And if we go to Asia, we've worked with East China Normal University. In fact, we have a young man, Mr. Liu, who's here for 2 years working with us, and we help them install the antenna and software packages for their processing system for their students to use for research and their degrees. And these are a set of the first set of products from IMAPP that they created, including Google Earth, their first IMAPP true color entry in Google Earth. We also worked with the Taiwan Central Weather Bureau, who requested from us to make a super domain for DD Crafts. This is the forecast 11 micron satellite imagery, because they're very interested in typhoon tracks. This is their domain. In Australia, we know that they use a lot of different software. They use a lot of satellite data. And this is just an example from a 2010 report from the Western Australia Satellite Technology and Applications Consortium, WESTAC, where they actually display a couple notice images, a couple IMAPP notice images, including cloud top temperature and cloud effective radius. And then Jackie Marsden, who works for WESTAC, actually sent me, this is their IDEA domain in their implementation of it. And I would be remiss if I didn't talk about polar regions for a polar orbiting satellite, where they get lots of passes, and it's even more valuable then. And this is an example of IMAPP products displayed in Jeff Key's real-time web pages. In this case, this is from McMurdo, and this is supporting Tromsø, Norway. And then this is an image of Jeff's product in IMAPP, the ice surface temperature over Antarctica, really cold. This data was acquired at the McMurdo site with the antenna data that's being processed from a machine with Matt Lazar's group, the AMRC, and I'm trying to say that right, but I'm not. It's Matt Lazar's machine, but the IMAPP software is running there. This is really cool data. Okay, then beta to the global IMAPP workshops. So people ask us if we can acquire the data, process it, and create these nice products, how would we use them? So we've traveled to China and Norway, South Africa. We went to Brazil and taught a workshop that was part of GEOS. And since 2009, we started teaching strictly applications-based workshop. So for example, in IGARS, we taught a short course there that was, along with the SIR folks, MODIS direct broadcast data for enhanced forecasting and real-time environmental decision-making. And then in September of 2011, we taught a workshop that was part of Region 5 WMO training on satellite applications for meteorology and climatology. And we release all the lectures, all the software, all the data, all the tools that we use through this website. It's all available there online. And this is a picture of Liam, that's Alan, teaching lecturing during one of the workshop days. And this is an image of all the happy attendees there. And the last thing I want to talk about is the fact that it's really important for us that these products have scientific integrity so that people can actually do science and research with the work. So when I was writing out the progress report for IMAPP this year, I went and did a Google Scholar search on IMAPP, and it turned up 18 referee journal articles that mention IMAPP. And here's a set of examples, including one from our own center. There's a group in India, characteristics of recent gust storms, using real-time multi-satellite observations. There's one from Iran looking at soil salinity. There's a group in China that was looking at flooding. And then there's a group from Spain that was looking at surface water vapor pressure. And then finally, as part of the search, it turned up a paper that was published just this year, summarizing the first 10 years of NASA's Aqua mission by Claire Parkinson, the Aqua project scientist. And within that publication, there's a section called Practical Applications, Weather Forecasting, and they have a whole paragraph that's devoted to IMAPP, which is a surprise and a privilege for us to be mentioned there. So in conclusion, CIMSS continues a history of supporting direct broadcast global satellite community, and the free distribution of the data, the software, the visualization tools has resulted in just a huge explosion of the use of the data in a wide variety of applications that we never foresaw. And we believe that future packages that might even include geostationary satellites will do the same for those future satellites, and we sure hope to be part of that. And then I thought I'd just show that we're working on things for IMAPP that include Collection 6 updates, extension of IDEA-I to include ERS and CRIS and EASI, ozone and trace gas trajectories, and we're going to include MODIS as part of the Polar to Grid suite of products. For CSPP, we're working on VIRS EDRs, aerosol sea surface temperature. We're working on Andy's CollaborX software, which we hope to package up and release this year as part of CSPP. We're also working with, Graham Mark is working at releasing CRIS full spectral resolution software. And then the last thing I wanted to say is that we're actually having a CSPP IMAPP users group meeting in 2 weeks here in Madison. So thank you.
All right, we have time for a question or two. There's a lot of stuff going on.
Didn't even show up.
And of course, going back